Lep pozdrav vsem, ki ste se zbrali na tem webinarju na temo AMR robotov, torej nekako robotskih vozičkov. Danes bo fokus o teh vozičkih, samo o njihovi uporabi v proizvodnji. Večinoma ste tudi iz proizvodnih podjetij, tudi iz trgovskih, ampak na temo proizvodnje imamo največ izkušenj na temo teh robotskih vozičkov, tam je tudi največ koristi. Takole je agenda za danes predvidena. Najprej bom jaz naredil kratek uvod, samo par minut, potem se nam bo pridružil gospod Adam Olson iz Zebre, ki bo malo bolj konkretno povedal o portfoliju zebrinih AMR robotih, o koristih, kako se lotiti projektov, kje so najbolj pomembne točke, tudi kje največ koristi lahko, in mislim, da bo sproti tudi par svojih projektov oziroma zebrinih projektov po Evropi opisal. Tako da planiramo 10:40 danes končati, jaz mislim, da morda še kakšno minutko prej. Bomo probali biti čim bolj konkretni in tudi kakšna vaša vprašanja odgovoriti. Na takle način lahko vprašanja me zastavite. Vprašanje je najbolj enostavno oziroma edino možnost imate, da jih vtipkate. Na tako oranžno puščico bi morali imeti na ekranu in ko tisto kliknete, se vam potem odpre možnost za vnos vašega vprašanja. Vprašanje bomo samo mi, organizatorji, slišali, torej lahko tudi nam direktno, kaj zastavite vprašanje, drugi jih ne vidijo. Ali bomo pa kasneje, ali tekom webinarja odgovorili, vas pokličemo, se bomo že potem pogovorili. Torej, kakršnakoli vprašanja imate, najboljše, da kar vtipkate v tale ekranček, ki bomo poskrbeli, da dobite odgovor tako ali drugače. Zdaj, tole je edini moj slajd, tak malo bolj konkreten, potem bom zadeve prepustil. Dostikrat, ko se pogovarjam z vami na temo teh robotskih vozičkov, se omenja neka AGV kratica, torej AGV tehnologija je neke vrste stara tehnologija, te roboti oziroma te vozički AGV so potrebovali ali pa potrebujejo na tleh neka vodila, neke črte, vozijo samo po tistih svojih poteh, ne znajo zaviti levo, desno, ne znajo se izogibati en drugemu. Torej danes bomo govorili, pa zadnja leta večinoma govorimo o AMR vozičkih, to so vozički, ki ne potrebujejo nobenih vodil v tleh, vozijo z lastnimi senzorji, nadomeščajo lahko viličarista, tudi njegovo usposabljanje, torej zna sam zavijati, sam in tja se izogibati in ljudem in tem fiksnim oviram. In ni treba v prostoru nič narediti, razen to, da ga mi, naši inženirji, prvič začetno peljejo po prostoru, kjer bo voziček vozil, da se spozna s prostorom, torej to je mapiranje prostora, in Wi-Fi potrebuje. Cel nadzorni sistem teh robotskih vozičkov je v oblaku, torej tudi v vašo računalniško infrastrukturo ni potrebno posegati. Proizvajalec Zebra tudi zagotavlja popolno varnost v skladu s predpisi v EU-ju, torej te robotski vozički, AMR, Zebra, Fetch, robotski vozički lahko funkcionirajo v istem prostoru z ljudmi, torej hkrati hodijo ljudje in vozički in se izogibajo eden drugega. Zdaj, bolj konkretno o teh zadevah bo tehle recimo modelih, ki so na razpolago, bo Adam razložil tudi nekaj konkretnih primerov, tako kot sem rekel, tole cel portfolio Zebre na temo robotskih vozičkov. Danes bomo govorili bolj o tehle zgornjih, torej teh manjših, neopaletnih, ker so ta manjši bolj primerni za to, kar smo mi ugotovili v proizvodnji. Tale recimo ima fiksne tele regale gor, tale ta drugi lahko ta regal z artikli nekje pusti, pa se odpelje nekaj drugega delati. Torej več modelov je in o teh bo Adam nekaj več razložil in ta trenutek bi tudi Adama Olsona povabil. So Adam, welcome to our webinar regarding AMRs, regarding Zebra portfolio and your experience and so on. Let's try and switch to you. We will make you already panelist, I believe, so you can start sharing your screen and continue with your presentation. Go ahead, Adam.
All right, thank you, Andre. And hopefully everybody can see my screen now and the slide that we're going to start with. So if not, Andre, please let me know, but I assume you can see what we're supposed to be looking at. Good morning, everybody. It's a pleasure to be with you. As Andre introduced me, I'm Adam Olson from Zebra Technologies. I work in our mobile robotics or robotics automation team, and I work with our partners across the European region to support end customers in adopting these new robotics technologies from Zebra. So I thought I would start off today by just talking about some of the things that we're seeing as we talk with customers in the market. And you know, these kinds of trends are very consistent across especially the North American and the European markets. And I'm sure that some of you are seeing these as well. So, today's supply chain, it would be an understatement to say that it has become quite complex. And we saw how challenging that could be in COVID and post-COVID with the disruption that caused. Probably the biggest challenge that we hear when we talk with our customers is about the availability of labor. So being able to find and retain enough workers for manufacturing plants and warehouse environments. There's a tremendous amount of uncertainty that our customers are facing as they see a need to produce higher volume of products and do higher volume of order picking. Inventory mixes are becoming more unpredictable, and it's harder than ever to forecast demand and availability. And then a lot of that comes down to the disruption that we see from the on-demand economy. So, as the consumer preferences and requirements have evolved, there's a rapid growth of e-commerce, and that's been great for us as shoppers. But it means that customers expect much shorter delivery times, a variety of products to be delivered on nearly real time, and technology innovation is really being required to enable these new consumer preferences. So from a Zebra point of view, I'm sure that many of you on this webinar know us from our traditional technologies, and really what Zebra's business is built on is around enabling field workers, whether that be in a manufacturing plant or a warehouse or a retail store. Our objective with our technologies is to be able to give enterprises the capability to be able to detect, sense, analyze, and action data from the field. So you see that with some of our traditional technologies around enterprise mobile computing, printing, scanning, RFID. And robotics automation is really kind of a natural next step for us as we see those challenges that our customers are facing. As you think about, we've been enabling for a long time workers in warehouses and manufacturing plants with, for example, mobile computers. And now as the labor is constrained and the workers are looking for a more technology-enabled environment, robots are a really great fit to take over some of these repetitive material handling tasks, and we'll talk about some of those now. So, what differentiates what Zebra does with automation from kind of traditional automation is we have a very flexible system-driven approach. So in legacy operations and for a lot of customers, what they're still seeing in their sites, you have a lot of manual movement, inflexible fixed infrastructure that ultimately leads to unproductive walking and unproductive movement between aisles and throughout workflows. So with robotics automation solutions like Zebra is offering, you can take robots to do fully autonomous transport of materials that are in different workflows in the warehouse that tend to be repetitive and long distance, where you can leverage robots to do that work and get workers focused on higher value tasks. With the robots today, you can do flexible multi-directional movement versus in the past with some of the fixed infrastructure, it was one directional. And as we implement robots into these sites, we're, like I said, able to efficiently augment workforces to help increase productivity, throughput, and ultimately reclaim valuable warehouse space with flexible automation solutions. I wanted to give you some examples today before the call, or before this webinar. Andre described to me that some of you are coming from a manufacturing background, some are coming from a retail or a warehousing background. So thinking about these environments, we have a few examples of workflows where we found that robotic solutions can be very helpful. So in the manufacturing plant, one of the first places we see in the process is robots being used to receive materials and to put those materials away. There's typically a distance that needs to be traveled between the receiving dock and where put away is happening, and it's a regular repetitive movement. So robots can help to automate that process and decrease dock to stock cycle times. By far the biggest use case that we've seen so far in manufacturing has been around getting materials and goods into, through, and out of production lines. So as you think about delivering materials to assembly lines from, say, a parts store, materials, tools, a lot of the time there's workers that are doing that work where they're taking a cart or a trolley, and they're going to a parts store, they're bringing materials to the assembly line. And oftentimes in today's environment with that labor shortage, what we're seeing is that the actual technicians or the people that are doing the production in the line are ending up having to do these tasks. And it's really dramatically impacting productivity. So the first step would be getting materials into the production lines. In a lot of assembly processes, it's a work in process or work in progress production schedule. And so you have work cell to work cell deliveries that need to happen of these work in process goods. So the robots can be very helpful for automating that movement. And then definitely the end of line handling. So once you have finished goods in an assembly line and they've been packaged up, getting them from the end of the assembly line to the dispatch area or to the shipping area to be shipped out to customers, and driving on-time deliveries is another use case that we've really seen. And that goes hand in hand with what we call shipping lane delivery, which is in some cases delivering pallets to a shipping dock for shipping. So those are just some of the use cases in the manufacturing plant. In a warehouse environment, some similar use cases and some unique use cases. So put away again exists in a warehouse environment. Goods that come into a warehouse need to be put into stock, and robots can help with that task. Replenishment, this is obviously a task that is very important, or a workflow that's very important to ensure that daily throughput rates are where they need to be in an operation. So the robots can be very helpful, especially for those SKUs that are regularly at high volume needing to be replenished. Building a schedule where the robots automate that movement of goods, we've seen a lot of customers benefit from. A unique use case in a warehouse environment that we've seen customers adopting has been what we call dunnage removal. And this is essentially taking trash and recycling materials that are being collected throughout the day in bins, and using the robots to take full bins to a baling system or to the exit point in the building, and then bringing empty bins back to the place where the collection happens. So we see a lot of customers doing that as what we would call a secondary use case, where maybe the primary use case could be something like replenishment or put away, and then when the robots are underutilized and they're available, they can be used for a task like dunnage removal. End of line handling exists in a warehouse environment as well. Perhaps you have a kitting process, or maybe imagine like a packaging or a picking process that's being supported by ASRS, or maybe goods to person picking robots. You can imagine that there the picked items need to go from that picking and packing desk to shipping, and robots can be helpful for that task, as well as shipping lane delivery. So one use case, knowing that many of you are coming from a manufacturing environment, that we wanted to highlight is this line side delivery workflow, and go into that in a little bit more detail. So we talked about some of the challenges that in a manufacturing environment you are likely facing: labor shortages, capacity constraints, linear bottlenecks, and deployment flexibility. All of these things come together, and they form an environment where robots can be extremely helpful to augment the field workers. So in a traditional environment, what we found is that a lot of the time, material delivery to production lines is happening via a manual cart transportation. So workers spending over 50% of their time walking materials from place to place in a warehouse. This could equate to up to 15 miles per day in large facilities. Great for your step count, daily step count, but not really sustainable as the workforce ages. And younger workers too, they want to do more fulfilling work, and just walking long distances in a warehouse isn't described typically as one of the most fulfilling work tasks. So what we see, as I've mentioned earlier, is that oftentimes you end up having skilled technicians doing some of these material deliveries, and that can have a huge impact on productivity. A lot of companies that we've been working with have already dabbled in automation and robotics with AGVs. So Andre described the difference earlier between an AMR, which is the technology Zebra provides, and an AGV. But AGVs being used, they've been a somewhat effective tool in the past at automating material delivery into assembly lines, but they travel on fixed paths only. They require a lot of infrastructure to deploy, and anytime you want to make a change to the workflow, you have to update that infrastructure, and so there's significant costs that's associated. And because they do simple collision avoidance and they're on kind of fixed paths, you can end up with bottlenecks easily, or you have to be very thoughtful about caging off the areas where the AGVs work. So there are some downsides of AGVs. So with what we're doing with our AMR-based line-side delivery, it offers a much more flexible solution to customers. So I wanted to give you an example of one of our customers today, a company called Bespoke Manufacturing Company in the United States. They're a custom apparel manufacturer, and they've had a great experience at moving from a production environment that was primarily based on a fixed conveyor system to a flexible conveyor system with our robotics automation systems. So in a nutshell, BMC, they basically help small fashion designers to take their fashion designs, procure the materials to make them, manage the production process, and then even the shipping process to end customers. So some of the challenges that they were facing when we started working with them were, of course, shortage of labor. They were struggling to find enough workers to manage this process. They had very high customer expectations in terms of a high variability of the order types. You know, very low quantity production runs of pretty specialized fashion and apparel products, but that needed to be produced to a high quality standard. So they also had low manufacturing efficiency because of the fixed nature of their automation system. It was very inflexible, and it took up a lot of space as well. So they had a high percentage of their floor space just dedicated to conveyor systems. So what we worked with them on, and with a partner that we teamed with on this project, was a solution that involves our roller top AMRs, which are a virtual conveyor AMR, that get loaded with the raw materials at the start of the production process. They take the raw materials to the first work cell in the production process. And then throughout the production process, we take the work in process goods from work cell to work cell. And then at the end of the process, when finished goods are ready, they're taken to the dispatch or the shipping area, and they're packed up and shipped out to end customers. And we're doing this, we're leveraging our software to intelligently manage this process together in integration with the customer's manufacturing execution system. So the benefits are, they've freed up a lot of space in the production facility. So 33% of their space they reclaimed. They have a lot more flexibility in the operation. They've increased their daily output by 3x. And they've been able to done that by being able to keep the skilled technicians focused on the assembly of these fashion products versus the movement of material. So this is what the facility looked like when we first started this engagement with BMC. And then after automation, we took all of that fixed conveyor system and replaced it with smaller conveyors that help to manage the movement from the start of the assembly process through the work cell delivery to the end of the process, and our flexible AMRs. So just to kind of show visually what this looks like, you've got the AMR going, it's picking up some raw materials at quote unquote parts store. The totes are labeled with barcodes, so we're using our vision systems as well to log the materials into the beginning of the production process. The work in process goods are moved, as I mentioned, from work cell to work cell. So you can see here the robots moving them from one work cell to the next. At each work cell, we've got the vision cameras capturing keeping track of the items as they go through that process. And then at the end, the finished goods are packed up and they're ready to get shipped out to customers. So that, in a nutshell, is what we're doing with BMC. So with that example in mind, we wanted to talk in a little bit more detail about our robotics portfolio and the platform. So, the most visual thing that you see when you look at Zebra's robotic systems in a site is the AMRs. But it's important to remember that the AMRs are managed by a centralized software application that we run in the cloud called FetchCore. So we have one software application that manages the robots, the maps of sites, the workflows that the robots need to execute, integrations with other IoT devices in the site or with other software applications that basically trigger the workflows happening. And then our system notifies these other systems when the work is done. And we have a range of robots available to suit multiple material handling workflows within an environment. So we just showed the example in BMC with the roller top AMR. So that's really an AMR that is designed to manage workflows where you're moving materials from a conveyor system to another conveyor system. We have a couple of different shelf-based AMR systems. So we have an HMI shelf, and then the next generation of that product is called a flex shelf. So here we can, we can fit a variety of different tote sizes, adjust the shelving to maximize the payload. All of our 100 series robots will carry up to 100 kilograms total weight. That's why we call them the Freight 100 robots. And with the HMI shelf and the flex shelf, they come with HMI screens that are integrated, and that helps to drive the worker experience. So basically on the screen, it tells the worker what to do, and when they're done, they can push a button depending on the workflow to send the robot to the next step in the process. We also have a cart-based system, so what we call a Cart Connect. And this is a robot that comes with a variety of different carts, some that have shelves, some that have large bins to handle that trash and recycling removal. This is probably the most popular robot that we have because it suits the widest range of workflows in an environment. So once we understand the workflows that make the most sense to apply robotics automation to in a site, then we choose the right systems that we need to execute those workflows. Oh, and in the future, we have coming a pallet transportation robot called the Pallet Transport 1500. This robot holds up to 1,500 kilograms. And essentially, this is a robot that can move pallets from place to place. So imagine a use case like receiving to put away. That would be ideally suited to a robot like the Pallet Transport. So like I mentioned, we have all of these robots are part of what we call our FetchCore ecosystem. So FetchCore is our cloud-based SaaS offering, and the application essentially enables the robots to be deployed quickly, to adjust the work that they are doing quickly and easily to make the system very scalable. It has within FetchCore you manage the users, you manage the robots, you manage the maps that they're navigating, the workflows that the robots need to execute, integration with software and other third-party devices. From a cloud point of view, some customers prefer different cloud providers, so it's available via Google Cloud, AWS, or Azure. And then obviously, like I mentioned, the software will manage all of our fleet of robot types. So you can control and manage all of the robots in one place. And then importantly, the software application has a very nice analytics dashboard capability. And really what you use that for is to understand the efficiency of the robot implementation in the site and to make changes to make the robots more utilized and more productive, ultimately driving the the outcomes that you're looking for in the business operation. So, looking quickly at mapping, one of the first steps that you do when you deploy a robot into a site is you connect the robot to the network, and then it's paired with the software in the cloud and the instance for that site. You build the map of the environment. So this is what a map looks like after it's been built. It's a very simple process. You actually use a joystick to drive the robot around the facility and use the 3D cameras and the LiDAR sensor to build this base map. And then once you have the base map built, you can build in keep out zones. If there's an area that you don't want the robots to navigate into, you can design that. You can limit speed in certain areas, or you can increase speed. So an example why you might want to do that is in an open area where there's limited, where there's not very much dynamics of workers or forklifts or other obstacles. You can have the speed be at maximum speed in that area, or if you know that there's an area where there's going to be a lot of dynamics, you might want to slow the speed down to help the robot navigate more efficiently. And you can annotate the map, obviously, with preferred paths and places where the charging docks are going to be, or where carts need to get picked up, et cetera, where a conveyor system might be. Once you have the map built, the next step is to take the workflow builder and actually build the workflows that you want the robots to go and execute. So one of the big differentiators for our system is the way we do this is via Blockly style interface. So you literally just go on the left side of the screen here and you drag over and drop the actions that you want the robot to take. So that could be as simple as something like robot pick up a pick up a cart in receiving that's been loaded up with priority goods that need to get to a replenishment area. Pick up that cart from defined point A and take it to defined point B using a preferred path, and do that when a barcode is scanned or when a worker taps a button that you've built into an application running on a mobile device. So basically, you take the workflow builder, you build the actions that you want the robots to take in different workflows, and then you have your workflows built. You can have those operate completely within FetchCore, or you can start to trigger activity with external systems. And then just to show you a little bit about the analytics, like I mentioned, we have a sophisticated analytics dashboard with FetchCore that gives you insight about things like robot utilization, average wait times, total stops per position, and these are just some of the examples of metrics that you might want to look at, but they ultimately can be used to drive the efficiency of the solution in the installation. And then last, just to show a little bit about what this looks like when you do integration between different devices and systems. Just imagine again, FetchCore sits at the center of this ecosystem. The AMRs execute the work, and that can be triggered by applications coming like a WMS or an MES, or by other devices. So imagine conveyor systems, sensors, vision cameras, and other equipment. So this is together to fully automate workflows in a manufacturing plant or a warehouse environment. And I think that's my last slide.
Adam, thank you for the presentation, for your slides, for the information. Could we talk a bit more about a new device that you have in your portfolio? That's the Flex Shelf, right? Could you put its picture back on the screen? I believe that's let's say a device that has a screen on top. That's the right one, right? Here on your screen. Yeah.
Yeah, exactly. Let me pull that up here in more
And it has
detail.
also, if I remember right, some lights that show the worker where to put or what is the bin that they need to use.
Yeah, exactly. So the HMI shelf that you see on the left was kind of the first generation of our shelf-based system with an integrated HMI for worker interface. And what we learned over time was that in different sites, the box sizes that need to be loaded or the tote sizes can be different. So that is why the first thing we did was we made the shelving system flexible, so you can have 1, 2, 3, up to 4 different shelves at different configurations to maximize the payload that the robots are carrying. To your point, Andre, another thing that we did is we added LEDs down the side of the robot so that we could do a pick to light or a put to light kind of application, where make it even more intuitive for the worker where they needed to go to take an item out of the robot or put an item into the robot. We have options now for 1 or 2 screens. So in the picture, we're showing the 1 screen option, but there's also an option for 2 screens on the Flex Shelf. It's something for the future, but it has an integrated NFC reader as well. So imagine in the future, as we have a solution that's in development to do high volume order picking, where we'll manage the entire process from the tote loading, manage the entire picking process from optimizing and orchestrating the picking, all the way from the totes being loaded into the robots, the picking being done in the most efficient way where workers get dedicated into defined but dynamic zones to pack out. You can imagine the workers could be wearing like an NFC wristband to identify themselves, and they could log into that step in the picking process using the NFC reader. So just a lot of learnings that we had with the HMI shelf of added functionality we could build into the robot to make it do applicable for more workflows in the warehouse environment.
Great, and you just touched the point that I want to continue discussion with you regarding the triggering. You have two devices now which have the touch screens, kind of a tablet. That's the second and the fourth one on your screen. What about the middle device, Card Connect, which is mostly used? How it's triggered? The worker cannot press a button on it. Does it use something else?
Yeah, that's a really good question. So it can be as simple as it's operating on a schedule that you define within FetchCore, or as complex as it's being triggered by commands from a manufacturing execution system or a warehouse management system, or anything in between. What we find is that most customers start at the simpler end of things, where they have either the robots running on a schedule, or they're utilizing some form of trigger within FetchCore to get the robots to execute workflows. And then over time they become more sophisticated and they start to integrate with other systems. But yeah, there's a wide range of ways that you can trigger the robot to do work. And just remember, it all kind of comes back to the robots in FetchCore. They're operating within these maps. You build the workflows that you want them to do, and then you can trigger these workflows with a wide range of capability that we just talked about.
I just see on behind me in here a device that is very usually used in the, let's say, manufacturing on the warehouses. So the warehouse worker can use also a device like this with a touch screen to call a robot, or to send a robot on some other destination. That's clear. Thank you, Adam, again. I just have one slide before we finish. Let me share my screen now, just a second. And
as you're doing that, Andre, I guess I would make one more point on this concept that you were talking about with devices. So obviously Zebra is a company with a tremendous amount of experience of devices that enable edge workers to execute and digitize different workflows. That's really a design principle in our robotics system, is we've designed it to be utilized with other devices. We want it to be flexible and open to leverage infrastructure that customers might have. We don't want the robots to operate as their own siloed solution. We want them to be part of an enterprise technology strategy for our customers.
Adam, thank you. Let's switch to our language, to Slovenian language, to connect with our listeners. Adama smo zdaj veliko slišali teh raznih detaljev, kako robote, kako funkcionirajo, kakšne so koristi. Zdaj, po mojih izkušnjah je tole, kar imamo zdaj na ekranu, pravzaprav tisto glavno, kar morate začeti razmišljati, ko začnete razmišljati o teh raznih robotskih vozičkih in podobnih zadevah. Zdaj, tle so fizikalne omejitve, torej kako velik je tovor, ki ga želite prevažati, kako težek je tovor, ki ga želite prevažati, koliko imate široke hodnike za prevažati. Dostikrat smo prišli do situacij, da želijo prevažati tovor 100 cm širok, hodnik je pa 120 samo širok. In so te detalji, ki jih je treba dobro razmisliti. Včasih je treba tudi kakšno stvar v proizvodnji malo spremeniti, ampak ni to toliko zelo pomembno. Koliko izmen imate, v koliko izmenah se funkcionira, torej malo to fizikalni del je fino, da malo pogledate. Kakšna tla, koliko je vrat, koliko dvigal in podobno. Pa ne nazadnje, vsak nas bo ali pa nas vedno vpraša, kakšno korist ima, kakšen povratek te investicije. Torej malo pogledajte, koliko delovnih mest bi se dalo nadomestiti s temi robotskimi vozički, to je osnovno, kjer se išče nek povratek investicije, je pa še kakšne drugi detalji so, kjer se da neke koristi takih uvajanja teh robotov uvajati. Jaz bi zdaj, ker gledamo to, da smo nekako točno po predvidenem času, 10:35 počas zaključil, slišali se bomo z vsemi, poklical vas bom, probal dobiti na telefon, da se pogovorimo, če so kakšne konkretne zadeve in še kakšno vprašanje lahko tudi natipkate, z veseljem bomo odgovorili. Sicer pa veste, da se Špica ukvarja poleg teh robotskih vozičkov seveda tudi recimo z VMS skladiščnimi sistemi, z tiskanjem, označevanjem, črtna koda, RFID, čitalci črtne kode, vse razne zadeve, ki pridejo prav v proizvodni, trgovini in distribuciji. Še enkrat se vam zahvaljujem za vašo prisotnost, za pozornost. Jaz sem vam na razpolago za vprašanja, bodi si po mailu ali se pa slišimo, ali pa moji kolegi, ki jih verjetno poznate, ki imajo kontakt z vami. Hvala lepa, nasvidenje.